Hey guys, in this video we're going to be talking about rotations in the coordinate plane, and I'm going to be doing that with the aid of this paper right here, this handout, because it already has the image already done for us to be able to rotate. And I'm going to be talking also about the two-sided transfer technique when doing rotations or any transformation in general. So rotations in the coordinate plane. What you need to know for this is you need to know which way is clockwise, which is to the right. If you're going this way in this orientation, that will be clockwise, or counterclockwise, meaning to the left. So you have to know which direction is which. Sometimes they tell you left, sometimes they'll tell you right, sometimes they'll tell you counterclockwise, sometimes they'll tell you clockwise. So we got to be really, really careful about that. So make sure that that we know where it is that they want us to rotate. So the easiest way to perform rotations is to use patty paper or tracing paper. So if you have tracing paper or patty paper, this is your best bet because it allows you to perform transformations really easily. All you have to do is trace the image. So we're going to be doing the very, very first one. And I'm not only going to be tracing the image, I'm going to actually trace the arrow that lets me know which way is up and which one is the center of rotation. So one of the things that we can do here when performing a rotation is called the two-sided transfer technique. And what it is you basically trace the image on the front side, flip it over, trace the image on the back side of the tracing paper. So now I have pencil marks on both the front and the back. And if you do it this way, you're able to perform the rotation, and something will happen once you actually perform the rotation and retrace it. And that is that the image will transfer itself onto the bottom paper. So let's try it out. So here we have this image that we're trying to rotate. It says to the left 90 degrees, right? So I'm going to be turning it to the left as if I'm turning the wheel of a car, 90 degrees, which means I'm going to be stopping right about there. And if you notice, the arrow should line up directly with the horizontal arrow. That we're very sure about where it should stop. So if I trace it again, what you will notice is that since I have pencil markings on the back of this, then when I peel off the paper, the image will transfer. So this is called the two-sided transfer technique. So it's used when you want to transfer an image onto the bottom of another paper using tracing paper. So there you go, that is the first one. So let's say we want to make another one real quick. I'm going to be using part of this tracing paper again. So here I want to turn it to the right 90 degrees. So again, the center of rotation is the origin. So I'm going to be making the X and Y axis. I'm going to be tracing the image with respect to that original location. Okay, so I have all these done. I'm going to be flipping it on the other side, right? So now I'm flipping it, the tracing paper on the other side. That way I can use the two-sided transfer technique to transfer it onto the bottom of the page. So trace it, shade it in. Back to this paper. I'm going to be turning this to the right 90 degrees. So starting here to the right would be this way. Before it was to the left, now this was to the right. So pretend you're turning the wheel of a car. If you want to turn right, you would turn it this way, right? So once I'm happy at the final location, I'm going to go ahead and stop and retrace it. And if you did it correctly, then the image should actually go on the other paper that you're originally in. So just to make it permanent, I'm going to make it dark again. This will go to that will go to that. And I have my image that has been rotated to the left first 90 degrees and to the right 90 degrees. We'll do one more in case you didn't get the point across for this. We'll do one more and we'll have this image, which is going to be rotated to the left 180 degrees. So I'm going to be making my y-axis and I'm going to be making my x-axis. That way I can identify the center of rotation, which is the middle or the origin. So there you go. I traced the image. Now I'm going to shade the back of it. I flipped the tracing paper on the other side. I'm going to trace the back of it. I'm going to shade it in. That way I have my image and my pencil markings on both sides of the tracing paper or the patty paper. And then I'm going to be back to the original paper so we can perform the transformation, which in this case is a rotation to the left 180 degrees. So let's do it. So we have the center of rotation. I'm turning it to the left. We need to think about like the wheel of a car. If you want to turn to the left, you would turn this way. So to the left or counterclockwise, 180. So that would be 90 degrees right there if I were to stop. But I want to go 180, so I want to do it one more time. And then it stops right about there. If I go back to the very beginning, let's say I went to the right 180 degrees, so I could go 90 degrees to the right, 180 degrees to the right, it'll end up on the exact same spot. So if you notice, it doesn't really matter if you go to the right or to the left, you'll end up at the same spot as long as you do a 180 degree rotation. And that is the only time that it will actually end up on the same original spot as if you go right or left. So retrace the image and you have your image rotated 180 degrees, in this case to the left. So I'm just going to reshade it. Don't worry if it's not perfect, it's okay. Just to get the idea of rotations and how do they work. So if you notice, the center of rotation is the origin for these shapes, right? That center of rotation for every single one of the points, the new point and the old point will be the same. All those distances will be the same as to the center of rotation. So from this point to that point, it'll be 2 squares. From this point to that point, it'll be 2 squares no matter what. If I go all the way to the edge, so that's 1, 2, 3, 4 squares up on the original image, 1, 2, 3, 4 squares on the new image. And that applies for every single one of these shapes. So let's jump down to the questions. What happens to the center under a rotation? Well, the center, right, the middle, the origin in this case, stays the same. So it stays in original location. The center does not move. The center of rotation. What happens to every other point under a rotation? So all the other points rotate, right? So they basically relocate to a different spot. Under rotation, do you think that segments are taken to segments of the same length? What that means is that is the segment the same distance as the original, as in the new? And that would be a yes. Sorry, I'm being very quick and to the point for this video because I want to not make it extra lengthy. Are the angles and the angles of the same measure the same? Well, yeah. Does the shape get any bigger or smaller, or are the angles the same? No, it all stays perfectly the same, right? The last question, are parallel lines parallel in both the new and the original image? Well, yes. Parallel lines stay parallel, right? If you look at the image that we just rotated here, this was parallel to this side, and when we rotated it, it was still parallel, right? So that side was parallel to that side. So there you go. I hope that kind of clarifies rotations for you guys if you guys were having trouble with it. The only thing that we need to look at now is how do rotations affect in terms of the coordinates? Like, is there a shortcut that we can use instead of having to use patty paper every single time? Because that kind of sucks, right? So let's look at problems 1 and let's look at problems, let's see, what do we do? 1, 2, and 3? Sure, let's look at problems 1, 2, and 3, the ones that we did, and we're going to make a conjecture about the rotation. So for problem number 1, it says rotate this to the left 90 degrees, right? So I'm going to be making a couple points that I want to call. Let's say this point, and this point. Now in my original image, this point was at 2, 0. This point right here, if we graph it, it's at 2, 1. And this point right here is at 1 to the right, 1, 2, 3, 4. So 1, 4. So that's our original image. Now let's look at those same exact points on the new image, which if you look at it, when we rotate it, we get this one, we get that one, and we get that one, right? This one right here, I go 4 to the left, 1 up. So that's -4, 1. On this one, I get 1 to the left, 2 up. So -1, 2. And on the last one, I get 0, 2. So let me write it right here. It's a little cluttered, but whatever. So there you go. I have my original points and I have my new points. So let's write it on this page here. So for problem number 1, my original point was 1, 4, 2, 1, and then 2, 0. But my new point was negative 4, 1, negative 1, 2, and the last one was 0, 2. So what happened? If you notice, the x and the y flipped, right? It flipped on the other side. So 2, 1 became 1, 2, and then 2, 0 became 0, 2, and then 1, 4 became 4, 1. And then the first term in front of it became negative. So all we do is we flip x and y, and we make x negative. So essentially, what we do when we perform a rotation to the left 90 degrees is we basically flip the x and the y. So now this is going to be here, this is going to be there. And then we make the number in the front negative. Now here I put x negative because that was the first one, but this is essentially what's going on for a rotation. So this is a rotation to the left 90 degrees. What does that mean? That means that if you have any problem at all in which you have to do a rotation and it's to the left 90 degrees, all you got to do is follow this rule. You don't even need patty paper. You don't need to graph anything. You just need to follow the rule, and then it'll actually work out. So let's see if we can come up with some more rules, and then that way we don't have to be doing this every single time. So let's look at image number 2. And I think 2 points for this will be good enough for the second one. So let's say we rotate this to the right 90 degrees, all right? So I want this, and I want this point, or my original image. So that's negative 2, 1. And then on this one, it's going to be negative 2, 1, 2, 3. So negative 2, 3. So I have my original, and I have my new points, which are the back of the arrow. I know it says 3, but I think 2 is good enough for now. So 1 to the right, 1, 2. And then 1, 2, 3 to the right, 1, 2. So 3, 2. So let's write these down. Let's see what the pattern is for rotation to the right 90 degrees. So originally I had negative 2, 3, and I had negative 2, 1. And that turned into a 3, 2. And that also turned into a 1, 2. Notice that the same deal happens, right? So we flip the x and the y. So flip x and y, right? So 2, 3 became 3, 2. And then the back one became opposite. If you notice that the negative 2 no longer is a negative. So now, what does this mean? This means that if you want to rotate to the right 90 degrees, we flip x and y, and we make this time the y negative. So the one in the back, I should say. So if we're looking at x and y, right, that was originally x and y in that orientation. We're going to flip them, so it's going to be y and then x, and then we're going to make the back one negative, so this is going to become negative here. So again, rotation to the right 90 degrees, you can actually skip all the tracing and the nonsense and